Yes, good morning everyone. I'm Dr. A.Siva Kumar, is Assistant Professor in CMRCET, the Department of Mathematics. Now, today's section, we have to discuss the chain rule of partial differentiation. Suppose the function is nothing but f of u comma b, where u is nothing but the function of the two variables x, y, and also v is also another function of x comma y, that is the two variables. Then the chain rule can be represent dou z by dou x is equal to dou z by dou u into dou u by dou x plus dou z by dou v into dou v by dou x, and with respect to y, dou z by dou y equals dou z by dou u into dou u by dou y plus dou z by dou v into dou v by dou y. So these are refers referred as a chain rule of partial differentiation. Partial differentiation. Okay, now z is a function f of uv, that is the u is nothing but another function x comma y, and v is another function xy. Now that is the chain rule can be represent dou z by dou x with respect to x, dou z by dou u into dou u by dou x plus dou z by dou v into dou v by dou x. Now dou z by dou y is equal with respect to y, dou z by dou u into dou u by dou y plus dou z by dou v into dou v by dou y. This is for the chain rule of partial differentiations. Now the total differential coefficients let z is equal to the two variables f of x comma y. So here x is equal to pi of t and y is nothing but g of t. So the function z is equal to f of x comma y, x is nothing but converted into the t variable and y is also converted into the t variable. So substituting x comma y in the function f of x comma y, so then z becomes a function of a single variable t. So now z is equal to f of x comma y, then x is equal to y of t and y is equal to g of t. Now substituting x comma y in the z function, now z is becomes the single variable, that is t. So now the dou z by dou t is called total differential coefficients. Okay, now dou z by dou t is can be represent dou z by dou x into dou x by dou t plus dou z by dou y into dou y by dou t. And similarly, dou u by dou t. So u is a function of x comma y. Can be represented dou u by dou x into dou x by dou t plus dou u by dou y to dou y by dou t. So here this is called total differential coefficients. Total differential coefficients. So u is another variable. There are three variables or x, y, z can be expanded for the total coefficients. Okay. See, in the total differential coefficients, the problems, first problem, u is equal to x square plus y square is a depends on the variable x comma y, and v is equal to a t square x is equal to a t square, y is equal to 2at. Yes, find dou u by dou t. Okay, now the solution, given function u is equal to x square plus y square. Okay, and x is represented for at square, y is represented for 2at. That is equation 1. Now we can find the dou u by dou x. With respect to x, y is a constant, that is a 2x. Dou u by dou y. With respect to y, x is a constant, that is a 2y. Now dou x by dou t is represented for the 2at. Dou by dou t of t square is nothing but 2at. A is a constant. And dou y by dou t is a 2a. Hence, dou u by dou t is the total derivative can be represented of the coefficient dou u by dou x into dou x by dou t plus can be extended dou u with respect to u and with respect to y, dou y by dou t. So now 2x, dou u by dou x is the 2x and dou x by dou t is nothing but 2at plus 2y into 2a. Now from equation 1, from x is equal to at square and y is equal to at. From equation 1, so 4at into at square, x is nothing but at square plus 4a into y is nothing but 2at. Now the value is 4a square t cubed plus a square t. So the common is a 4a square t is t square plus 1. So this is by using the total differential coefficient. Now we can get the result is a single variable, that is the t. So you can find the dou u by dou t. This is the one problem. Okay. Okay. Now the second problem. If u is equal to f of 2x minus 3y, comma 3y minus 4z, comma 4x minus 2x, 4z minus 2x, then prove that 1 by 2 into dou u by dou x plus 1 by 3 into dou u by dou y plus 1 by 4th into dou u by dou z equals 0. Now we have to prove that 1 by u into dou u by dou x plus 1 by 3 into dou u by dou y 1 by 4th into dou u by dou z is equal to 0. Now the solution, the given function u is equal to, that depends on the x variable x, u, y, z, that is the three variables are there. F of 2x minus 3y, comma 3y minus 4z, comma 4z minus 2x. So here can be reference for here r is equal, this is for r, s and t. Okay, here r is equal 2x minus 3y. Now x is equal to 3y minus 4z and t is equal to 4z minus 2x. Now we can apply for the by chain rule. By chain rule of partial differentiation, we have first of all we will represent dou u by dou x, afterwards dou u by dou y and dou u by dou z. Now we can result is 1 by 2 plus 1 by 3 plus 1 by 4 equals 0. So what is the chain rule apply for three variables x, y, z? Dou u by dou r by dou x plus dou u by dou s into dou s by dou x plus dou u by dou t or st dou u by dou t into dou t by dou x with respect to x. Okay, so you know that dou u by dou r into dou r by dou x value is 2 plus dou u by dou s into 0 plus dou u by dou t by dou x value is minus 2. So now 2 into 2 is a common, dou u by dou r minus dou u by dou t. So dou u by dou x equals. So implies it can be written as the equation 1 by 2 into dou u by dou x equals dou u by dou r minus dou u by dou t. So that is the equation 1. So similarly you can find the dou u by dou y. Dou u by dou y equals, so dou u by dou r into dou r by dou y with respect to y, dou u by dou y. So dou u by dou r into dou r by dou y plus dou u by dou s into dou s by dou y plus dou u by dou t into dou t by dou y. So you know that value dou r by dou y, dou s by dou y, dou t by dou y. Okay, dou u by dou r into minus 3 plus dou u by dou x into 3 plus dou u by dou t into 0. So the now value the 3 is a common, dou u by dou s minus dou u by dou r. So dou u by dou y. So implies this equation can be written as 1 by 3 into dou u by dou y equals dou u by dou s minus dou u by dou r. That is equation 2. At the same way, you can determine for dou u by dou z. So same as can be applied for the total partial coefficients, dou u by dou r by dou z plus dou u by dou s dou s by dou z plus dou u by dou t into dou t by dou z. You know the determined values dou r by dou z and dou s by dou z and dou t by dou z, right? Okay, dou u by dou r into 0 plus dou u by dou s into minus 1 is nothing but minus 4 minus 4 plus dou u by dou t to 4. Now the 4 is a common dou u by dou t minus dou u by dou s. You know that dou u by dou z. So now that implies it can be written as the equation 1 by 4th into dou u by dou z equals dou u by dou t minus dou u by dou s. That is equation 3. So adding equation 1, 2, 3, it gives adding equations 1 plus 2 plus 3 gives, okay, now 1 by 2 into dou u by dou x plus 1 by 3 into dou u by dou y plus 1 by 4th into dou u by dou z equals dou u by dou r minus dou u by dou t plus dou u by dou s minus dou u by dou r plus dou u by dou t minus dou u by dou s. So all r will be cancelled, that is equals to 0. Therefore 1 by 2 into dou u by dou x plus 1 by 3 into dou u by dou y plus 1 by 4th into dou u by dou z equals 0. So this is the solution. We can find the partial differential coefficients. Okay, so they have the three variables are there, x, y and z. Okay, move the next one problem. So now if u is equal f of r s t, so r is a defined, s is a defined, and t is a defined, where r is equal to x by y, s is equal to y by z, and t equals z by x. Then show that x into dou u by dou x plus y into dou u by dou y plus z into dou u by dou z equals 0. Okay, so the function is f of r s t. R is a defined, s is a defined, and t is a defined. Okay, now the solution. Given u is equal f of r s t and r is nothing but x by y and s is equal to y by z and t is equal to z by x. Therefore, we can determine for the dou u by dou x is equal to 1 by y, dou r by dou y equals minus x by y square. Dou x by dou x is nothing but 1 by y. Okay, next one, dou r by dou z is equal to 0 and dou s by dou x equals 0, dou s by dou y is equal to 1 by z, dou s by dou z is equal to minus y by z square. So, and now dou t by dou x or xt with respect to x minus z by x square, dou t by dou y is equal to 0. Now dou t by dou z is equal to 1 by x. So we can apply for the partial differential coefficient of the chain rule. By chain rule, of partial differentiation, we have, first of all, we can determine for the dou u by dou x. So by chain rule of the partial differential coefficient, that is a dou u by dou r to dou r by dou x plus dou u by dou s into dou s by dou x plus dou u by dou t into dou t by dou x. Now the substituting value dou r by dou x, dou s by dou x and dou t by dou x. Now that is dou u by dou r into 1 by y plus dou u by dou x into 0 plus dou u by dou t into minus z by x square. Now the result is that dou u by dou x equals 1 by y dou u by dou r minus z by x square dou u by dou t. You can multiple x into, the result is nothing but x into dou u by dou x plus y into dou u by dou y plus z into dou u by dou y. So now x into dou u by dou x equals, now x by y dou u by dou r minus 1x will cancel, that is for z by x into dou u by dou t, x by x square, so z by x, that is equation 1. Now we can determine for the same the chain rule of the partial differential with respect to y. Now dou u by dou y equals dou u by dou r by chain rule plus into dou r by dou y plus with respect to s, dou u by dou s into dou s by dou y, again t, dou u by dou t into dou t by dou y. So you know that dou r by dou y, dou s by dou y, dou t by dou y values. Okay, dou u by dou r into minus x by y square plus dou u by dou s into 1 by z plus dou u by dou t into 0. So the result is dou u by dou y equals minus x by y square dou u by dou r plus, that is a 0, third one 0, 1 by z into dou u by dou s. Now we can determine multiple y into both sides with respect to y, multiple with y into dou u by dou y is equal to minus x by y by y square, that is the result is minus x by y dou u by dou r plus 1 by z into dou u by dou s. That is the equation 2. Now we can determine for the dou u by dou z with respect to RST of the total, there is dou u by dou r into dou r by dou z plus dou u by dou s into dou s by dou z plus dou u by dou t into dou t by dou z. Now the result is dou u by dou z equals minus y by z square dou u by dou s plus 1 by x into dou u by dou t. Okay. Now result therefore z into dou u by dou z is equal to minus y by z dou u by dou s plus z by x dou u by dou t. That is equation 3. So adding 1 plus 2 plus 3 gives the result is x into dou u by dou x plus y into dou u by dou y plus z into dou u by dou z equals x by y plus x by y dou u by dou r minus z by x dou u by dou t, the first equation, plus the second equation minus x by y dou u by dou r plus y by z dou u by dou s. Now the third equation minus y by z dou u by dou s plus z by x dou u by dou t. All are cancelled, that is equal to 0. Therefore, x into dou u by dou x plus y into dou u by dou y plus z into dou u by dou z equals 0. So this is the total partial differential coefficient by using the chain rule. Okay. Okay. Thank you. Thank you everyone.